Right, grade 11s, we're going to continue with compound interest today. Remember that compound interest is interest that is earned on the principal and on interest. So our equation that we have is exponential growth. Our principal, or our initial value, times the rate to the power of the number of compounding periods. So interest on interest, which is why it grows so wonderfully over time. Let's calculate the amount and the interest paid on the $700 loan after 3 years at 6% per annum, compounded semi-annually. So our formula involves an interest rate and a number of compounding periods which change if you're not compounding annually, and we're not. We're compounding semi-annually. I always do my work over to the side. Number of compounding periods is how many times your banker sits down and calculates your interest. He does it for 3 years, twice a year, semi-annually. So 6 times he is going to add interest into your account on top of interest. The interest rate is 6% or 0.06, but they can't give you 6% twice a year or they're going to go broke. So they're going to divide by 2 and give you 3% twice a year. Now we can use our formula. $700 loan is your principal. The rate is 0.03 compounded 6 times. So our overall amount is $835.84. Please speak to me if your calculator is giving you any grief, and we'll figure it out. The interest is the amount, subtract what was originally put into the investment. So the interest will be $135.84. Miranda puts $2,500 into an RRSP plan, Registered Retirement Savings Plan, that earns 7.5% per annum. Goodness sakes. Determine the amount of the investment after 8 years if A, it's compounded annually, and B, it's compounded weekly. That should make a significant difference even in 8 years. The more often it's compounded, the more interest you should earn. Not huge amounts different, but a little bit different. So let's put them in 2 piles. Let's do the annually here, and let's do the weekly here. For annually, nothing changes. You've got 7.5% per annum annually. Your I is 0.075. N is once a year for 8 years. If it's annually, your N will be 8. So my formula, putting in the numbers she's putting in, $2,500 as her principal. 1 plus I is 1.075 to the power of 8. So the total amount will be, and I trust that you are pausing to use your calculator. This seems larger than I thought, so I'm going to write it down and check it once again. $4,458.69, rounding to 2 decimal places. I'm just going to check. Yep, it's all right. Fair bit of interest. If you compound it weekly, both the I and the N will change. Your I, which was 0.075 per year, and if it's compounded weekly, is divided by 52. 0.075 divided by 52, and the more you can leave in your calculator, the better. 0.001442307. The number of times the interest is calculated is 8 years, and 52 times each year will be 416 times that your interest is compounded, added to your principal amount. Principal, interest rate times the number of compounding periods. So $2,500 1 decimal 0.0144423 to the power of 416. The amount is 4553 decimal 31. So $100 more or less extra by compounding weekly, which doesn't seem like a lot, but if it were something like a mortgage, it could make a significant difference. Now we're going to look at questions in a little bit of a different way. What interest rate compounded annually is required for a $200 investment to amount to $250 in 4 years? So, what interest rate do I need to earn $50 in interest? So this is the only formula we have, filling in what we know. We want the final amount to be $250 with an investment of $200. I want to know the interest rate in 4 years, and it's compounded annually, so the number of times they are going to add interest would be exactly 4. I need to solve that for I. We are undoing that equation to get I by itself. It's like peeling an onion. We're going to divide both sides by 200 first of all, and we have 1.25 equals 1 plus I to the power of 4. The next thing I want to get rid of, so we do this first. We're going to do that second. How do we get rid of to the power of 4? What is the opposite of to the power of 4? That would be take the fourth root of both sides. 1.25. You can write it in two ways. Fourth root is the 4 in the little house. Fourth root, or you can write 1.25 to the 1/4. If you do 1.25 to the power of 1/4, you will get 1.057. So our I value, if we subtract 1 from both sides, is 0.057 or 5.7%. So our focus for today is what principal should somebody deposit? This is called a present value question. What should I do now in order to meet my goal? He wants to have $500 in 8 years. He can get 5.75%. So what does he have to invest now to get that $500? We've only got the one formula. We're going to substitute what we know and solve for P. He wants to end up with $500. We have 5.75% compounded annually. I don't have to adjust my I. It is annually, so 1 decimal. 5.75% as a decimal is 0.0575. Be careful. In 8 years, compounded annually would be 8 compounds. So to get the principal, or the present value, what I need to invest now, I'm going to do a division. 500 divided by 1.0575 to the 8. Think about reasonable answers before you type it in. How much would you have to invest to get $500? 400 and something would be reasonable. 100 and something, not so much. 319.69 is what he needs to invest at that great rate to get $500 in 8 years. David opened a savings account. The interest rate is 4.75% compounded quarterly. Oopsie. He wants $3,000 in 4 years. This is a present value problem. What do I need to do now in order to get something in the future? What principal should he deposit now? So again, remember, we are going to end up doing a division. The only formula that we have is this one. Let's fill in what we know. Do we need to adjust our I and our N? Yes, we do, because it's quarterly. So I and N are both adjusted by 4 times per year. So the interest rate is 0.0475, and I'm going to divide by quarterly, which is dividing by 4. It's not pretty, but it's 0.011875. So 1 and a bit percent quarterly. Our N is 4 times a year for 4 years. They're going to compound your interest 16 times. We want to end up with $3,000, so that's our amount. We want to figure out what the principal is to get that amount. 1.0111875 to the power of 16. To get the principal, or the present value, we end up doing a division. $3,000, divide both sides by 1.011875 to the 16. Make friends with your brackets. The principal is approximately $2,483.66. If you've ever gone into a bank and you are talking about loans or investments, your banker will often grab a calculator and do some calculations for you to give you some information. This is what they're doing. This formula, compound interest. But you're well aware of the fact that when you do something officially, they're going to use their computer. We're going to use the graphing calculators. They would do very similar things on their computer to figure out the information officially and give you a loan, a mortgage, or an investment. These graphing calculators can really be your friend if you're not afraid of them. We are going to do David's problem all over again using the graphing calculator. It would really be helpful to you. Okay. All right, this is about as clear as I can make it. It started running all by itself again, so I'm sorry for wasting your time. Let's set this thing up. First of all, we want to make sure it will show as money to 2 decimal places. I mean, you can round yourself, but our mode button, which is right here, if we push that, I guess turning it on is helpful. Mode button, and you go down to the second row. We're going to put it to 2 decimal places for money. Our financial application is an app. So you want an app for that, the blue one. And our financial option is the first option. Option number 1. TVM solver is what you want, number 1. And that will get us to this screen where it has N, I, PV, PMT, FV, PY, and so on. So let's write down what some of those things mean. N is the number of compounds. So if it is not annually, you will have to do the calculation. Number of years times the number of compounding periods, just like we use it in our formula, N. I is a percent. You do not have to do this as a decimal. That is your rate. You do not have to calculate that adjusted for the number of compound periods. It will adjust that. Sorry, not as a decimal. I apologize. So I is, if it were 8%, you would write an 8 in there. Percent per annum. PV is the present value. We've been using P for principal. Present value is what it actually stands for. Payment, we haven't gotten to yet, but if you had a mortgage or a loan and you were paying it off monthly, you would use PMT for payment. We're going to use the letter R. FV is your future value. We've been using the letter A. The amount in the end when all the interest is added. P per Y we're not going to use, so you can kind of gently cross that one off and gently cross that one off, because that's only when you do regular payments. Payments per year would be like your mortgage. You would pay monthly. Payments per year. C/Y is your number of compounds per year. So if it was semi-annually, you would put the number 2 in there. Let's put the numbers in for David's problem. So David had an interest rate of 4 3/4%. So we need to type that in there exactly as we see it, 4 3/4%. We see also that it's compounded quarterly, so I'm going to go down to compounds per year and change that to a 4. He wants $3,000 in 4 years, so the $3,000 is his future value that he wants to end up with, $3,000. In 4 years, that will affect the number of compounds. So it's 4 years compounded quarterly. There will be 12. Good. I lied to you. I'm glad I caught it now instead of later. Our N is the number of years for compound interest questions. So N in this case is going to be, let's stroke that out and make it years, for compound interest questions. You can hear that I'm giving you a hint for something coming along, but it will be 4 for this case because he had 4 years. Let's change that to a 4. And we have entered all of our information that we have. Payment is 0, and payment per year will leave as 1 because he's not doing a regular payment. It's a one-time investment that he's just earning interest on. What does he have to invest to get that? We scroll down to P or PV to find out what he needs to invest now to get that future value of $3,000. To get the calculator to answer, give you a value somewhere, you scroll to that place and hit alpha, which is a green button, / enter. So I'm going to this button right here, alpha, and then hit enter, and you get 2483.66. Notice that it is negative. That means that money comes out of your pocket. The 3,000 is positive. That's what you get. That's a good thing. The negative is out of your pocket. Our answer is 2483.66. And it is the same answer as we got by hand. Page 498, 3 to 11. And I would love you to try a couple of those with the graphing calculator.